Okay, in the next part of this chapter, I will explain the next important concept. We call it intrinsic and extrinsic semiconductor. So first, what is the term intrinsic mean? Intrinsic means pure, so pure semiconductor. While extrinsic mean the material or the semiconductor that has foreign atom added. So intrinsic silicon means that the material that has only silicon atom inside it. But extrinsic material silicons means that there are small amount of foreign atom, or here we call it impurities. Sometimes we call it impurities, foreign atom or impurities added inside the silicon. So there's many reasons why we need to add another atoms or another element inside the silicon. One of the process of the addition of the foreign atom or impurities is a doping process. Okay, so this is doping process. Doping process is a very important process in the semiconductor device fabrication. So what is doping process? Doping process is we add impurities, or here in this context we call the impurities as a dopant atom to increase the number of electron or hole. Okay, as we have discussed in the previous part, electron and hole are the carrier of the material. Carrier. So electron and hole are the carrier. This is a carrier. So sometimes we want to increase the number of electron. Sometimes we want to increase the number of hole carrier. So it depends on your application. So how we can increase the number of electron or hole is by doing the doping process. Okay, so when we add these impurities or foreign atom, so the material will become extrinsic semiconductor, and then extrinsic semiconductor has two types, which is N type, and here refer to the negative, and P type. P type is positive type. N type or P type. So we have N type silicon or P type silicon. Okay, in the previous part of the slide that explaining on why the material conducts electricity, we have one statement that explain about the electron hole pair generation. Electron hole pair. So electron hole pair means that one electron will produce one hole, because the release of valence electron will leave behind one vacancy, that we call it hole. So the number of electron and hole should be same, because it is in pair. So in extrinsic silicon, it has same number of electron and hole carrier. But however, when a dopant or foreign atom is added, this balance or this condition will not be applicable anymore. So there are two possible change. So number one, the number of electron is higher than number of hole. So electron carrier is higher than number of hole carrier. So this is what we call it N-type silicon, because electron is negative charge. So we call it negative type silicon. So in this N-type silicon, the majority carrier is electron, because number of electron is higher, and then the minority carrier is hole. Okay, and then the next possible case is when the number of hole is higher than number of electron. Okay, remember this is the first case is electron is higher. Now second case is hole is higher. So hole is positively charged. So we call it P-type silicon. So here the majority carrier is hole and the minority carrier is electron. So in this slide, the term of majority carrier, majority and minority carrier is highlighted. I want to highlight the term of majority and minority carrier in semiconductor. Okay, we look at the example of N-type silicon. So this is the image show the arrangement of silicon atom. So I have briefly explained about the covalent bonding between the intersilicon atom. So intersilicon atom will sharing valence electron to make a, this is the valence, it's covalent bonding. Okay, so what if we put, instead of silicon here, we put a phosphorus. P is a phosphorus. So phosphorus is from group 15. We call it pentavalent because penta means 5, valent. So it has 5 valence electron. Phosphorus is a pentavalent, has 5 valence electron. So what happened? This is belong to the phosphorus. It has 5. 1, 2, 3, 4, and 5. So we have the extra electron, which don't have any seat, which don't have any place to go. So this is extra free electron. So that's why when we add the phosphorus or we add a pentavalent material inside the silicon, there will be more electron compared to the whole. So this is why we call it N-type silicon. So next is example of P-type silicon. Okay, instead of phosphorus, we replace with the boron. Boron is from group 13. We call it, this B is a boron. B is boron, is from group 13. So group 13 we call it trivalent because it has 3 valence electron. So have 3 valence electrons, 1, 2, 3. So we have this vacancy is not filled by any electron. So we have extra hole. So that's why more number of hole inside a P-type silicon. Okay, this table summarizes the important concept of extrinsic semiconductor. So extrinsic semiconductor has 2 types, N-type and P-type. And how we can produce the N-type silicon is by adding a pentavalent. For example, is antimony, arsenic, and phosphorus. Okay, so why pentavalent? Because pentavalent has more electron, more valence electron than silicon. Silicon is 4 valence electron, pentavalent is 5 valence electron. So it has extra electron. So because of extra electron, the majority carrier is electron, minority carrier is hole. Okay, next is P-type. P-type, how to produce the P-type is by adding a 3-valent material such as boron, gallium, and indium. So because it has only 3 valence electron, so in the silicon we have extra vacancy. We call it hole. So the whole number of hole is higher than electron. Hole become majority carrier and electron become minority carrier.